Hi, I'm Jack Higginbotham. We are at the PRS factory in Stevensville, Maryland on the Eastern Shore, and today we're going to have a factory tour. We're going to focus on Core, S2, and our bolt-on series. We've been around now for more than 3 decades, which is a little strange to think about because it doesn't feel like we've been around for 3 decades. And a lot of the people inside of this company are the same people that walked through the doors in the 1980s. In a way, that continuity allows us to push and change. It allows us to be flexible. What isn't changing is our core principles of what makes a good guitar, and the discovery that comes along with that is what really drives us every day. That's the passion of making the guitar. That's the passion of chasing sound. Every day when we walk into this factory, we're basically walking in on a tightrope. And we are performing a balancing act in a lot of different ways. Some of those ways are the balance between history versus technology and where we're pushing the art of making guitars. Then there's the balance of the art of the guitar itself versus manufacturing. And then that leads us to the balance between manufacturing and machines versus the craftsmanship and handwork that goes into making a fine instrument. So let's go out on the factory floor and see some of the practices that we've talked about, watch some of those balancing acts that we've discussed, and see what we see. Hope you enjoy the tour. The first stop on our tour is in our rough cut. Guitar making is comprised of materials, design, and processes, and in rough cut, that's where we compile all of our materials. These materials form the foundation of the guitar. It creates the sound of the guitar from the woodworking point of view. Once we have these materials in-house, it's up to us to nurture them and to get everything we can out of this wood to make the very best guitar that we can. And that starts with the drying process. You have to be very careful with the drying of maple because curly maple is very sensitive and it actually can be easily damaged if you don't dry the wood correctly. So we start with an air drying process where the wood is book matched. Book matching is the process where we take a block of wood and bandsaw it in half on our horizontal mill, and it folds out just like the pages on a book. The wood is then put on a pallet and separated by stickers, just pieces of wood that separate them from each other so that air can flow between them and slowly dry the moisture off of the wood. Once we get that moisture content down to a reasonable level, we're then able to put the wood in our drying rooms where we have forced hot air that circulates in the room and again just slowly works the moisture out of the wood and gets it down to below what our humidity levels are in our factory. How well you dry that wood is directly correlated to how well that guitar is going to vibrate. It also has a direct correlation to how it will stay in tune. Because if you get that moisture out, you lock it down and that guitar becomes very stable. You still have to make sure you've got a quality bridge, quality tuner, a quality setup, that the nut is cut correctly out of the right materials. All of those things still can ruin a guitar easily, but you don't stand a chance of having a guitar that stays in tune if you don't have a stable platform. We divide our materials basically into 2 groups. We have our core materials and we have our S2 bolt-on materials. Inside of both of these groups, we use a grading process. So when you look through the factory and you see stacks of curly maple with different colors on the end of them, and it's basically that way so that we can quickly build a schedule, put our guitars together, and make guitars each day based upon the demand of the customers. Before we actually start building a guitar, there's a supporting cell, which is the inlay and fretboard cell. This is a cell that actually feeds virtually every aspect of the business. It starts with thickness sanding the material. So we take that wood that's out of our oven, we acclimate it in our wood shop, then we run it through our thickness sander and get it to the proper thickness of a final fretboard. Once the fretboard is thickness sanded, we take it to a CNC machine where we'll cut the outline of the guitar, and then we'll route the holes for the bird inlays or whatever the inlay is that's in that fretboard. The peghead veneer is also thickness sanded, and then it goes over to our CNC machine where we'll cut the perimeter, we'll cut the negative for the signature and the headstock, and then we'll cut the holes for the tuning pegs to go through. The fretboard that's also routed, and then the peg head veneer that is routed, then go to be inlaid. At inlay, we have a lot of options. We have cases of inlay material here that span many years. So we have the ability to mix and match and come up with a lot of fresh designs and ideas just based on what we've done in the past. Once we've selected that inlay material, we take the fretboard and we carefully glue each bird in place. We glue the signature into the peg head veneer. That's cured, and then we have a finished fretboard and peg head veneer set that's ready for manufacturing. So now we have our wood selected, and we have a fretboard, and we need a neck. Making a neck has always been a very fascinating process to me because it's a complicated thing. And if you get it right, it's really right. And if you don't get it right, it can go wrong in several different ways. It's a precision subcomponent of making a guitar. S2, bolt-on, and core all have slightly different processes, but they really share the same goal. And the goal is to have that good neck. It has to be stable. It has to be tonal. It has to be generally very dense and very resonant. This neck process is something that I did in the 80s, and I really grew to love it. So S2 was created at a time that we needed to learn how to make a different price point, and we were looking to bring a new player into the PRS family. We all agreed that many things could change, but the thing we would not compromise on would be the integrity of the instrument based upon the neck, which is really at the heart of things. It takes about 1 month to make a core neck from start to finish. S2 and bolt-on take a fraction of the time because it's closer to the finished dimension. The neck blank itself is 4/4 instead of 12/4, so you're much closer to your final dimension, therefore you bypass a lot of the time. The way we're able to use a 4/4 neck blank instead of a 12/4 is with a very accurate cut that scarfs the headstock. So you make your very accurate cut on a very precise chop box, basically. You finish that off with a CNC operation and end up with 2 perfectly mating parts that, when flipped over and joined together, form our perfect headstock angle. The end of that neck blank is then cut off and is eventually glued to the bottom of the neck, and that forms the heel and where the neck pickup is going to rest upon. Once the headstock is scarfed and the heel is applied, the rest of the process is very similar between core, bolt-on, and S2 series. We slot the neck for a truss rod, install a double action truss rod. We then glue in a truss rod slot insert. We clamp that truss rod slot insert in the same fixtures that we ultimately will clamp the fretboard to the neck. When it sets, we remove it, we'll fly cut the surface, put our tooling holes in for the fretboard, and continue on the neck manufacturing process. After the fretboard and the neck have been glued together, we then go on to our carve program. Once the neck is carved, then we're ready to round, level, and fret. The rounding of the fretboard is first done on a CNC machine. From there on out comes a lot of handwork. The first stop on the handwork is the radius and leveling of the fretboard. This is used on an aluminum jig with a highly skilled craftsperson that will ensure that we have a perfect radius that's very consistent from the nut to the heel, and we also have a perfectly level fretboard from the nut to the heel. And once we have that perfect platform, then we go on to fretting. Fretting done perfectly will allow us to put a bead of glue in each fret slot, press in each fret perfectly consistent so that when we're finished with a very flat fretboard, radiused very well, we then have frets that are pressed in very equally. And by the time we go to level the frets in our finish process, there's very little material that we need to remove to make sure that that playing surface is absolutely perfect. Since the beginning of the company, we've been very careful to think about what are the applications that a machine should be used in and what are the operations that a skilled craftsman should be responsible for. In general, a machine can be used for very repetitive processes, but a craftsperson is absolutely essential in making sure that when you put your hands on that neck, it feels perfect, it's home, it's comfortable. That takes a person that understands what the guitar player wants to feel and can get that neck to that spot. We do a lot of work with the guitar by hand in the sanding operations. When compared to a neck, a body is a fairly simple thing to make. We start with a back and a book match top, and we laminate them together in our laminating press. The press is at a pressure between 6,500 pounds and about 7,500 pounds. So imagine a Chevrolet Suburban sitting on top of each of these stacks of bodies. That's about the downforce that we're using on these guitars. Some guitars are solid body guitars. They bypass that laminating process and they have no maple top, so it doesn't go through the book match. They simply are billets of wood that are glued together, joined, and planed. Then they're ready for their bandsaw cut, tooling holes, and ready for the CNC. The CNC operations for S2, CE, and Core are all very, very similar, except for the programs. We use a beveled carve for our S2 bodies. We use a shallow violin carve for our CE bolt-ons, and we use a contoured carve for the Silver Sky. Obviously, we use our traditional violin carve for our Core guitars. The first cuts on the CNC are what we call back cuts. The body is put in a fixture upside down, located by the tooling holes that we just drilled. The outside perimeter of the body is shaped. The belly carve is shaped. The electronics cavity is routed. If there is a tremolo cavity, that'll be routed here. The recesses for the back plates, and then the radius for the roundover on the back edge. The second CNC machine does all of our top cuts. It's going to take care of our violin carve, our neck pocket, pickup holes, tremolo through holes, the divots for the controls, or the wells for a stop tail guitar. That's all done on this second machine. When the body comes out of the CNC machine, the first step is to sand the flat surfaces, which we use a semi-automated panel sander that helps maintain a flat surface on both the top and on the back of the guitar. After the panel sander, we're basically sanding a body that's off of a CNC carving machine that has mill marks in it into a finished surface that's ready for staining. There's a couple of things that we're achieving when we're sanding a guitar body. First of all, it has to be the right shape. Secondly, it has to be absolutely scratch-free, because that's our challenge to ourselves, is to be able to look at a stained guitar and say that there are no defects or scratches or anything to detract from the beauty of the stain and the maple that's on the guitar. One of the keys of having a very good guitar is to have a very thin, very hard finish, and the requirement of that being able to be possible is the wood to be absolutely flat and true. Neck body assembly, or NBA, is where we make sure that it has a snug, tight fit between the neck and the body. The neck angle is struck so that we have the proper height on the tremolo or the stop tail. And we make sure that the neck and the bridge position line up accurately with our string gauges. Once the neck and the body are clamped, glue squeezes out of the neck joint, and we spend a lot of time making sure that we clean up not just what's on the surface, but we also have to be very careful to get any glue that has soaked into the pores of the wood, because this is going to show up inside of the staining operation and inside of the finish operations. Once the body and the neck are glued together, we basically have a finished guitar, and we're basically finished with the wood shop. In 1985, when we started the business, largely the electric guitar market was opaque colors, a lot of bright neons, really flashy guitars. And we came in and said, our signature is going to be curly maple, classic colors, but vibrant colors, and guitars that the beauty of the wood is part of what it is that's drawing you into the instrument. We started out the company with 3 colors. There was a vintage yellow, a scarlet red, and a royal blue. But over time, we've evolved those colors and those processes to be literally hundreds and hundreds and hundreds of colors. And a lot of creativity has gone into the vision of those colors and executing those colors. In a way, it culminates with what we started doing with our stain fades. After our stain process, we go to grain filling. We use a paste grain filler that's rubbed into the wood and then wiped off, which takes the open pores of the wood and fills them in, so you have a flat surface to build your base coat upon. After grain fill, we prep the guitar, tape off the fretboard, and the guitar is ready for base coat operations. What most people think of with finish is a protective surface. We agree with that. We're trying to protect the guitar, but more than anything, we think of it as a tonal process. Finish has a lot to do with what the guitar is going to sound like. You can kill a guitar by coating it with something that is very thick and not very hard and wrapping the outside of it with it. And that is something that we're very, very careful inside of our company to make sure we have very thin finishes, very hard finishes, and to make sure that the beauty of the guitar all comes through very clear finishes. From a very 30,000 foot point of view, a guitar should look good, feel good, and sound good, and finish is surprisingly a major part of executing those 3 fundamentals. When we apply our base coat, it's 1.5 human hairs thick. It's about 6/1000ths of an inch. Not much material on there to level off, so it has to be a perfect substrate. And base coat is one of the places where we believe a machine is capable of doing the job more consistently and accurately than a human. Because the goal of base coat is purely to put on a very thin, very even, very concise amount of material on the instrument. Just like a CNC machine, a robot is capable of doing this day in and day out exactly the same. After we sprayed the base coat, the guitar dries and is cured. After a couple of days, we sand the guitar body, level the surface, and it goes to spray prep. If a guitar has a black back or a tone back or a sunburst, we go into our color coding operations. A perfect sunburst is an art form, and it takes an artist to apply the sunburst on our guitars. Everybody does it a little bit differently. You can look at our guitars over the years and we can actually tell who the sprayer was that put on a particular sunburst because it's almost like a fingerprint. At the end of the color coding process, if we see a spot that may be a little bit light or needs a little bit of a touch-up, we can go to our touch-up booth and skillfully apply matching finish to even out that back or that neck. After color coding, we're ready for top coat. Very carefully, by hand, a sprayer manually sprays the coat onto the guitar, and it takes a very highly skilled craftsperson to apply the finish in the way that we need it sprayed in order to achieve really what is the look, the feel, and the sound of the instrument. By the time we've finished with our spray operations, the total thickness on our guitars is less than 2 human hairs thick. We've taken material and put it on, we've sanded it off, we've blocked the guitar, we've leveled it at base coat, and then we've done it at top coat. And at the very end of the process, we want to take that fretboard and essentially make it feel comfortable and familiar and like a guitar you've played all your life and it just came out of a case. We do that at fret level. This is also where we level the frets on our core guitars using straight sticks and make sure that the frets are absolutely level with each other. After the frets are leveled, then the top coat will be machine sanded and then hand sanded. The guitar will be inspected carefully and then go into our buffing room. When the guitar comes out of the buffing room, it's carefully critiqued to make sure there's no flaws and no issues in the guitar. If we see anything at this point of the process, the guitar can go back a step and be corrected, or it can be addressed there at the bench. We call this turnaround. We call it turnaround because in the beginning of the business, we only had one rack for the guitars coming out of the buffing room. If the guitar wasn't ready for final assembly, it faced towards the buffing room. When the guitar was ready for final assembly, we turned it around and it faced the final assembly room, so we just started calling it turnaround, and that stuck. Our bolt-on guitars are finished in a different way. Obviously, the neck is not in the body yet, so the body is sprayed separately and the neck is sprayed separately. They go through the sanding operation, they go through the buffing operation identically, but the neck and the body are mated together after the buffing process, where we find the matching pair, we check the neck angle, we screw the neck and the body together, and then the guitar is ready for the turnaround process. This is one of our major checkpoints for quality assurance. When the guitar is met with their approval, it goes into a rack and a guitar builder can select that guitar and start building it. But before we can make that guitar, we have to go to the electronics room. When we come into the electronics room, what we're really doing is coming into a room full of solutions. When Paul started out in the guitar world, he was repairing instruments. And as he was repairing those instruments, he was seeing why things broke or why things weren't performing the way that the guitarist wanted it to perform. And he was coming up with solutions to those problems. Ultimately, the solutions to many of those problems led to the design of many of the proprietary parts that we use. Whether it's our locking tuning pegs, our patented tremolo bridge, the Paul's guitar bridge with brass inserts, the pickups that we use, every part that's on this guitar isn't unique for the sake of being unique. It's unique because we feel like it's the best way that particular part can be designed and made with the materials that work best for that particular guitar. They're made to be high performance in nature, and in the right combination on each of the individual models, they come together to finish off the personality of that instrument. As we exit the electronics room, we go into assembly, where the room is divided into two sections. One section for pre-assembly and one section for final setup. Final assembly is where all of those components match up with the guitar and the guitar is born. Again, going back to Paul's history, I think what sets us apart to a degree within the industry is the quality of our setups. In addition to being a good repair guy and a great guitar builder, Paul was very well known for his setups, and he has very exacting standards for those setups. What this room has is the ability to take what he does at a very craftsman level, making a guitar feel very special and perfect, and scaling that to the manufacturing process. After the guitar is finished, the final assembler will fill out the hang tag, sign his name on it, write the specifics of the guitar on it, and date the guitar, and then the guitar goes into our quality assurance final inspection. We haven't talked a whole lot about quality control, but everywhere that we have gone on this tour, there have been elements of quality assurance and quality control. All through the manufacturing of the guitar, you'll also see people signing their initials in a guitar. We've done this since the beginning of the company. At PRS today, that tradition continues, but there are many more signatures because the guitars are focused on in individual areas much more carefully than they were 35 years ago. And when that guitar is signed off to go from one stage to another, the person responsible for saying that guitar is good puts their initials in the guitar. At final inspection, the guitar is play tested, make sure that everything about that guitar is performing the way that we want it to perform. At final casing, we're making sure the guitar looks perfect, has all the appropriate accessories with the guitar. Then the case is closed. The guitar goes into a box, it goes into our warehouse, and is preparing to go out to a customer. But there's one more stop along the way. On Friday mornings, we go into our warehouse and we randomly select the guitars that are preparing to be shipped. We pull those out of the shipments, we take them to our conference room, where our manufacturing managers and quality assurance come together and review the guitars to see where we stand on a quality level inside of the company. Generally speaking, we don't find problems with the guitars, but what we do have is an opportunity to think about how we can improve the processes or improve the guitars, and sometimes we'll even come up with ideas for new guitars for the future inside of this meeting. I hope some of you will decide to come to PRS and actually experience this firsthand. Thank you for watching the video. Thank you for taking our factory tour. And thank you most of all for being a part of the PRS family. We hope to see you soon.